Welcome to Mechanotechnics N6. Today's video is going to be on clutches. And before I begin, I just want to say that if you wish to have access to this study guide, you can contact me using the number in the description, and then we will see how we can make this available to you. For those of you that are studying using my videos, it can help to have the corresponding set of notes, the notes that I am using in the videos that you are watching, okay? So for Mechanotechnics N6 videos, I am using a study guide that I developed myself, and it is a study guide that is particularly useful because as I do not waste your time, okay? It is concise and precise, meaning it is short but straight to the point. And so you do not spend too much time reading what you might not really need for you to be able to prepare for your exam. The study guide is straight to the point, and in the study guide, I also go through past exam questions and various questions that are collected from various places. And I provide the solution to those, and you can just work through the study guide and quite very well prepare yourself for the exam. So, if this is something you will be interested in, you can just contact me using the number in the description, and then we will see how we can make that available to you. So, today's video is on clutches. So basically, what is a clutch? A clutch is a mechanical device that is used either to engage or to disengage power transmission. If you are doing Mechanotechnics N6, you definitely are acquainted with the term clutch. And the purpose of a clutch, as I said, is to engage or disengage power transmission. Okay, so you have power that is coming from the engine, okay, and that power has to be transmitted all the way to the wheels. Okay, I'm using the example of a vehicle. Okay, so the power from the engine must be transmitted all the way to the wheels so that then when the wheels are turning, they can move the car. But then how do you go about transmitting that power? You could transmit it directly without using a clutch. Let's assume somebody made a design like that. But then the issue with something like that is that it wouldn't be possible if the transmission was direct. It wouldn't be possible to change gears. Okay, so you will be limited to a certain gear to move at, and also it wouldn't be possible to go in reverse direction. So the direction in which the vehicle will be going, that will be the direction it will be stuck with for all its existence. Okay, but the but clutches and gearboxes make it possible to be able to select the speed at which we're going to move the gear that we're going to drive with. And also, the gearbox also has a setting that makes it possible to reverse the rotation of the shaft so that the vehicle can go backwards. Okay, so that is why gearboxes are very useful. But now, if you have a gearbox in a car, you will need to be able to engage the power transmission and to disengage it because you cannot change gears with the power that is coming from the engine still connected to the output shaft. You cannot do that, okay? You will need to disengage the driving shaft from the gearbox, and then you can select a gear and then re-engage again the driving shaft that is coming from the motor. Okay, that is the best way to do it if you wanna preserve your engine. Okay, and so when you are driving, when the clutch is not pressed, okay, that will mean that the power transmission is engaged. Okay, it is connected to the gearbox. Once you press the clutch, you disconnect the power transmission, okay, and then you can change gears, okay, and then reconnect again the power transmission, and with the new gear setting, then you can take that power according to the new gear setting and send it to the driven shaft, and then the wheels, and then the car will move according to the new gear that you have. Okay, so that is basically the purpose of clutches. Okay, very important. And so for Mechanotechnics N6, we will study three different types of clutches. First is the plate clutches, okay? As the name gives it away, clutches use basically friction between pairs of plates, okay? So you have pairs of contact surfaces and the friction between them, that is pretty much what is being used, okay? So torque is transmitted by friction at the side of the plates. Okay, and you can have one pair of contact surfaces, two pairs of contact surfaces, or even eight pairs of contact surfaces. So with plate clutches, you have more than one contact pair. Okay, so as the plates are contacting each other, there is friction that arises from that, and that frictional force can be used to create torque, which is then transmitted, and so on and so forth. Okay, so very important, plate clutches use pairs of contact surfaces. Okay, so very, very important. It's not just one, it can be two, three, depending on the type of question that you have. Okay, with a plate clutch, you can have more than one pair of contact surfaces. Okay, and so the equations that are very important with plate clutches are the ones that you see on the screen. First is the moment of inertia, okay? This equation here is that of the moment of inertia. And this is not to be confused with the moment of inertia that you study in strength of materials, okay? In strength of materials, you also have something that is called the moment of inertia, but that one is the area moment of inertia. The one that you have in mechanotechnics is the mass moment of inertia. And in fact, when you look at the equation for the moment of inertia in Mechano, you can see that it's different from the equation of the moment of inertia in strength of materials, because this one is related to the mass, whereas the one that you study in strength of materials is related to the area. So this is the mass moment of inertia. The one from strength of materials is the area moment of inertia. And so this moment of inertia here is equal to the mass multiplied by the radius of gyration squared. Okay, as you can see, I is equal to mk squared. Okay, and then you have the final speed. Okay, because when the clutch is engaged, one thing that you need to understand, you are engaging a driving shaft to a driven shaft, basically. Okay, of course you have many other components in between, but that's basically the goal. Okay, where the clutch allows you to engage a driving shaft which is coming from the engine to a driven shaft, okay, which is probably, if you go down the line, connected to the wheels, okay. And so we will refer therefore to components, or should I say variables from the engine with the subscript E, okay. So we will use the subscript E to refer to the engine and the subscript S to refer to the driven shaft, okay. So when we say the shaft, we really are referring to the driven shaft. And when we say the engine, we really are referring to the driving shaft. Okay. So therefore, the final speed, okay, which is that you see here in rotations per second, and here, okay, is in rotations per second. That final speed, okay, for a clutch is given by the angular acceleration of the driven shaft, which is alpha s, multiplied by the speed of the engine, which is going to be given in rotations per second. Okay, if the speed of the engine is given in rotations per second, the final speed n here is also going to be in rotations per second. If this speed is given in rotations per minute, ne, the speed of the engine, then the final speed is also going to be in rotations per minute, okay? So your unit must be consistent for both ends, okay? For both ends, the unit must be consistent. This is the speed of the engine, this is the final speed that you have. And so, as I was saying, the final speed is equal to the angular acceleration of the driven shaft, which is alpha s, multiplied by the speed of the engine divided by the angular acceleration of the driving shaft or of the engine, okay, plus the angular acceleration of the driven shaft, okay, which is alpha s, okay. Very important. Now, when you're dealing with clutches, there are also two theories that are very important, okay? And these theories are basically assumptions that we make to facilitate calculations, okay? So the first theory is what is referred to as uniform wear theory. And in this theory, we assume that the plates of the clutch are wearing more or less